So in this video, we're going to go through the next section, 3.3, on systems of linear inequalities. So we've already graphed linear inequalities, but now we're going to do two at the same time, and sometimes three lines at the same time. So if this were a system of equations, what we'd be looking for is we'd want to graph both lines and see where they cross. However, with inequalities, we're not just looking for the intersection point. But if I graph this on Desmos, this is what it looks like. So the first one by itself would look like this. We shade below the line because it's y is less than, minus 1 because that's the y-intercept, and then the slope is just going up by ones, up 1 over 1, up 1 over 1. So then I'm shading below this line, which means every point in this red region is a solution, except the points on the dashed electric fence. Those would not satisfy. If I put the second one on there by itself, it looks like this. The y-intercept is 0, and the slope is -2. So I go down to right 1, down to right 1. And I shade above the line because its y is greater than -2x. But if I look at them at the same time, notice there's one blue region, one red region, and one purple region. The purple region is the one we are looking for when we do these. These are the points that satisfy both of them at the same time. The red region only satisfies the red inequality, and the blue only satisfies the blue. So if I showed you a graph and I said, and I showed you a point and I said 6 and -2, does that point satisfy this system of inequalities? You would say yes, because it's in the shaded region, the overlapping shaded region. But a point here in the blue region or here in the red, you would say no, that is not a solution because it doesn't satisfy both at the same time. And then definitely if it's in the white region, it is not a solution. So we could look at the same thing algebraically and see, here's the ordered pair 6, -2, and we could just plug it in individually to each one. So -2 for y is less than 6 minus 1, and we see -2 is less than 5. So that's a solution. And then we could plug it into the second one. -2 is greater than -2x. So x is 6. So I'm going to multiply. -2 times 6 is -12. And yes, -2 is greater than -12. So it has to satisfy both of these. You could check it algebraically as well as graphically. So now I want to do another one where you really have to do this by hand. So this first inequality is already in slope-intercept form. So we just look at the y-intercept is 2, and the slope is 2/3. So I rise 2, run 3, and that's where another point is. I could also go down 2 and left 3 to get another point on there. And then since it's a strict inequality, I should make my line a dashed line, an electric fence. So there's my line. And I should think, okay, I'm going to shade above this line because it's greater than. So shade above, and I'm just going to sort of mentally shade above because when you're doing it by hand, you're doing it with a pencil or a pen and you only want to shade one region. You could use two different colors and then there would be an overlapping region, and that would be fine to do it that way as well. So I'm going to make this one the red one, and now I'm going to switch colors and let's make this one purple. So this one, I have some work to do before I can graph it. I really need to get it into slope-intercept form. So I'm going to add 2x to both sides and subtract 3 to both sides. So this less than is not going to change, but the 2x is going to become positive, and the plus 3 is going to become minus. And now I can divide both sides by 3, and I get 2/3 x, and then -3 divided by +3 is -1. So now I know the y-intercept is -1, and the slope is 2/3. So I rise 2, 2, 3. Rise, oops, I didn't rise enough there. I need to rise 2, 1, 2, run 1, 2, 3. And I don't have room here. I can go down 2, left 3. And now this is another dashed line. And I wish I had a line tool. I could make these lines straighter, and you would be able to see what's true about these lines. They are parallel, so they don't intersect. And we can see that because of the slopes. Now, I'm supposed to shade below this line, and I'm supposed to shade above the red line. So where is the overlapping region? The answer is there isn't one. So this is a case where there is no solution because there's no overlapping region. There is no point, there's no coordinates. Let's say the coordinates of this point does not satisfy both of these at the same time. It only satisfies one of them. So we would say this point is not a solution to the system. It's only a solution to one of them. The only way you could get a solution out of this is if we changed these signs. If for some reason this one, if the red one we changed to a less than, then we would have shaded below this red line, and then there would have been an overlap. Or if we would have changed this one to greater than, there could have also been an overlap. But in this case, we say that there is no solution. And another way to say that is like this with the empty set, no solution. So one more that I want to go through, and this is a system of 3 inequalities. So we can do this one first. Y-intercept is -2, and the slope is +1 over 1. So up 1, right 1, up 1, right 1. And so this is a greater than or equal to, so my line should be solid. And I'm going to shade above this, but only mentally for now. Shade above that line because it's greater than. Now this x is less than 3. Let's do this one in purple. This is a vertical line that has an x-intercept at 3. And it's a strict inequality, so it should be a dashed line. These should be perfectly vertical. And I'm going to shade to the left. Less than means to the left. And then we have this is going to be a horizontal line. So let's do that one in green. So this is going to have a y-intercept at 4. 1, 2, 3, 4. And it's also a solid line. So now I'm looking for, that's this one. I'm looking for the region where they all overlap. And so if I'm going to shade above the red line and to the left of the purple line and below the green line, then the overlapping region will be everything inside of here. So if you're doing this by hand, we would shade just this region unless you're using different colors. But ultimately, this is the region where any point inside of here would satisfy all 3 statements at the same time.